Students, it is the third lecture of Bayesian analysis of this week. Here I shared a question of predictive distributions. Listen attentively. The statement of the question, let x1, x2, x3 and so on denotes a random sample taken from a sequentially in time from a Poisson distribution with unknown mean theta. Before sampling begins, the prior distribution of theta is a gamma distribution. At a point in time when x1, x2, x3 up to xn has been observed, but not yet xn plus 1, determine the predictive distribution of xn plus 1. Now the likelihood function of the Poisson distribution as the sample is taken from Poisson distribution, product I varies from 1 to n e raised to power minus theta raised to power x over x factorial is equal to e raised to power minus n theta raised to power sum of x, x1 factorial, x2 factorial and so on, xn factorial. The prior distribution of theta is a gamma distribution which is given here. The posterior distribution of theta for the given data is equal in the form of density kernel proportional to p theta into p x over theta, which is equal to b raised to power a over a gamma, theta raised to power a minus 1, e raised to power minus b theta, e raised to power minus n theta raised to power sum of x divided by x1 factorial, x2 factorial and so on, xn factorial. Which is proportional to after dropping out the constant values, we have theta raised to power a plus we have proportional to theta raised to power a plus sum of x minus 1 e raised to power minus b plus n into theta, which is a gamma distribution parameter a plus x and b plus n, where alpha is equal to a plus x and beta is equal to b plus n. So theta over x is proportional to g alpha beta. Now the predict density of y is equal to xn plus 1 when the data is available, minus infinity to infinity p theta over x e y over theta d theta is equal to, after replacing the respective values, we have this expression and making certain simplifications and doing definite integration for the limit 0 to infinity theta raised to power alpha plus y minus 1 e raised to power minus b plus 1 e raised into e d theta. Here I have applied certain rules of definite integrations. Therefore it has become beta raised to power alpha or alpha gamma y factorial alpha plus y gamma divided by beta plus 1 raised to power alpha plus y. After making some simplifications, which you can observe here, we have 1 over alpha gamma into alpha plus 1 over beta raised to power alpha e raised to power minus log of alpha plus y gamma into b plus 1 raised to power minus 1 over y factorial. Now see the b part of this question. The loss function Ly theta is equal to 1 minus y over Ly d is equal to 1 minus y over d whole square is used for choosing a point predictive d of a positive valued random variable y. Show that this loss function prescribes the base point predictor d star is equal to expected value of y square divided by expected value of y, where the expectation are with respect to the predictive distribution of y. See the solution. Given the loss function L by d is equal to 1 minus y over d whole square. Open the square of this expression. The risk is given as expected value of y d is equal to 1 plus expected value of y square divided by d minus 2 expected value of y over d. D is a constant and y is a random variable, so expectation will be used with on y. Now, to minimize the risk, differentiate with respect to d and equating equal to 0. Here I have differentiate the above expression and equating the expression is equal to d is equal to 0, where d square d cube and d square is a constant. After multiplying both sides with respect to d square, I have the expression given here, this one, and from here I have d star is equal to expected value of y square and divided by expected value of y. Expected value of y square may be written as expected value of y square minus expected value of y whole square plus expected value of y whole square divided by expected value of y. Now above is the variance of expected value of y plus expected value of y. This and this will be expected value of y, and this will be the variance of expected value of y. Now the value of the point predictive found as under. Expected value of y may be written as k into 1 minus p divided by p. Variance of y is equal to k into 1 minus p over p square, and py over x is equal to alpha plus beta into alpha y factorial, beta over 1 plus beta raised to power alpha 1 plus beta raised to power minus 1. Put b over 1 plus beta over 1 plus beta is equal to p. We have this expression. After replacing the values and substituting in above equation, we have the negative binomial distribution of alpha beta. Y over x is a negative binomial distribution of alpha beta, which is equal to alpha plus y gamma over alpha gamma y factorial, beta raised to power alpha 1 minus p over y. Mean of this distribution is equal to alpha over beta, and variance of this distribution is equal to 1 alpha into 1 plus y raised to power minus 1 beta over 1 plus beta whole square. And the loss function, the base point predict is equal to d star is equal to variance of y expected value of y plus expected value of y.